These are the guided notes for 7.3 in Algebra 1. In this lesson, we are now looking at ax squared plus bx plus c. So that's the key here, is we've got this a, we have this b, and we have this c. We're going to use those three letters to help us figure out what's going on with the parabola. So first of all, we know that the graph is going upward, like this one here, where it's up, like a little smile, when our a is positive. Remember, a greater than 0 means positive, okay? And the graph is going to go downward, meaning it's going to look like a, whoops, that's not what I wanted to draw. It's going to look like this, downward, if our a is negative, okay? We want to find out what our y-intercept is. The y-intercept is where this parabola crosses the y-axis, and it's always the same point, and it is 0, c, the c from this equation. Okay? The x-coordinate of the vertex, here's my vertex right here. We're going to have an x, y, and the x-coordinate for this is found by using the letters a and b in a particular way. It's a formula, so you're going to write this down and use it over and over. It's negative b over 2a. So whatever the number is here, you want to do the opposite of it and divide by 2 times a. And that's going to be the x-coordinate for this point. Now this point has an x, y. How do we find the y-coordinate? Well, we take whatever number we got here and we plug it back into the equation. So like if this gets a 2, you're going to plug in a 2 for x. Okay? The axis of symmetry, which is that mirror line that goes straight through the vertex, is always the equation x equals negative b over 2a, the number you found when you found the x-coordinate for the vertex. So let's use this with an actual problem. With this problem, we have our a is 3, our b is negative 12, and our c is 4. To find the axes of symmetry, we're going to use that formula. Oh, I'm sorry. First of all, go ahead and put the point for the y-intercept. Remember, we use the c for our y-intercept. We just go right here at 4 and put a dot, because that's 0, 4. For the axes of symmetry, we're going to use negative b over 2a. Well, negative b would be the opposite of negative 12. So we're going to have negative 12, the opposite of negative 12, divided by 2 times my a, 2 times my 3. Well, this is going to be 12 divided by 6, which is 2. So this is my axis of symmetry, which means over here on the graph paper, at x equals 2, put a dashed line. Or I put it in blue, but you should put a dashed line. Now I'm going to state the vertex. The vertex starts with 2, and then what we need to do with this 2 is we need to plug in the 2 into this equation up here, and we're going to plug in 2 and figure out what our y is. So here we go. 3 times 2 squared minus 12 times 2 plus 4. You could just type this into your calculator the way it is, or you could calculate it out. 3 times 2 squared is 3 times 4, which is 12, minus 12 times 2, which is 24, plus 4, and we end up with negative 8. So we have a vertex that is 2, negative 8. This is our vertex. So we come over to our graph paper, and at positive 2, negative 8, put a point. Now we're going to graph. We've got the vertex. We have our y-intercept up here. But we need a few more points. So we're going to do the parabola dance. The parabola dance says go over 1 and up 1 squared times a. Well, 1 squared times a is 3. So we're going to go up 3 units. And then we'll have a mirror of that over our axis of symmetry. So we have those points. We also have the mirror, we have the mirror of this x-intercept to its point over here. So we went 2 units to the left, we're going to go 2 units to the right. And now, carefully connect those points. There we go. Okay. The domain and range, well, the domain is always all real numbers. The range is we're graphing everything above the vertex. So we're going to say that our range is above the vertex. How do we say above the vertex? We say y values greater than our negative x, greater than our c. All right. So what are the key ideas about maximum and minimums? We're going to talk about what's the maximum, what's the minimum. So the y-coordinate of the vertex is what we're going to be using. The y-coordinate, not the whole vertex, just the y-coordinate. And when we have a quadratic, ax squared plus bx plus c, the minimum value, because there's minimum values and there's maximum values, the minimum value is going to be when we have a positive a, and it's a maximum value when we have a negative a. So let's look at our problem that we just did, that example. When we have a upward, this is the minimum. When we have a downward, that's a maximum. So let's look at the problem we just did. We had 3x squared minus 12x plus 4. And this is what it looked like, right here. And we had the vertex, 2, negative 8. Well, this right here is the lowest point. So we say, oh, that's my minimum. And the value is how far down did it go? It went down to negative 8. So therefore, my minimum value, and that's the key, is the minimum value is negative 8. Then we're going to do one more problem together. And here it is. 2x squared minus 12x plus 6. First thing we want to do is recognize what is our a, what is our b, and what is our c. So my a is 2, my b is negative 12, my c is 6. We're going to find our vertex by using the negative b over 2a. So we're going to do the opposite of b and divide it by 2 times 2. So the opposite of negative 12 divided by 2 times 2, which means it's going to be 12 divided by 4, which is 3. Now we take this 3 and we plug it into the equation wherever I see x. So there it is. Plugging it into my calculator, we get negative 12. So my vertex is 3 comma negative 12. And this negative 12 is either the maximum or the minimum. Since my a is positive, it's going to be a minimum. Remember, being a positive implies that it's going to have a graph that looks upwards like this. And therefore, the minimum value is negative 12. What I want you to do is for the rest of the period, you can work together, and I want you to work on your classwork, and then we will check that on block day tomorrow.